Okay. I do this. Okay. Hey, let's focus. Okay. Just send us. No, where's the box? Oh, the box is right there. Yesterday I uploaded some stuff. I think I was able to upload a couple of videos. One of them was the pulleys. I know I was like, why am I even bothering with this now? But I was like, let me just get done with it. So I think I posted a couple or just one. I'm not sure. Two? Okay. But two in the energy unit or oh no, just okay. Just the work, which at least yeah, I still need to put the one for the cases. I will do that today. So if anyone needs any extra time for the quiz, that's absolutely fine. If you still need to watch the video to actually figure out how to do questions like the two numerical problems, no problem. It's my mistake that I took so long to actually post the video. Okay, so don't worry about that. Okay. Um, I did post so far just one filled. I'll post the other two fills today. Okay. All right. So today, listen up. Today, I want what reinforce what we learned yesterday about what conservation of energy. By the way, we said there are two principles, or technically three principles of conservation in the universe. We care about conservation of what? Energy in grade 11. In grade 12, we care about what and what? Conservation of energy and conservation of momentum. Technically, we can add another conservation of which chemists are very, very, very concerned conservation of matter or conservation of mass, which means what? 5 electrons go in, 5 electrons come out. 5 nitrogens come in, 5 nitrogens come out, and so on. Okay? All right. So, oh, one more thing. So, so far, the main two players in the energy game are what and what? Kinetic energy and gravitational energy. So, those are the players. Their combination, which could be called what? Total energy. No, we call it a very special name. We call it what? We call it the mechanical energy of the object or technically of the system. The system here being the what the ball and the earth, basically, in a way. Okay? All right. So let's look at the first problem. So 535 what? Grams. Okay, so we know that there's a what? There's a conversion coming up. Metal ball is held 1.6 meters above the ground. Okay, it is thrown upward, straight upward, with an initial speed of how much? 16.0 meters per second. Okay. On the diagram below, for each energy bar, fill each bar K for kinetic, G for gravitational, and M for mechanical total. According to the information about the motion of the ball, add that, it should be instance, not instant. Next to each diagram, do the calculations to find the value of the kinetic energy, gravitational, and the mechanical energy of the ball at that instant. By the way, a question very similar to this, with even the same diagram almost, will make it to your what? To your written test, for sure. Okay? Okay, so something like that. Yes. Okay, everyone, so let's start from here. Okay. Now, what do I know about the object at this instant, right at this moment? What do I know about it? Do I know its mass? Check. Do I know its speed? Right there. How much? 16 going straight up. Do I know its elevation? So am I able to calculate EK and EG and then EM? Let's go. All right. So everyone, in any order you want, EK or EG doesn't matter, but I usually like to start with EK. Okay. What is the equation? Come on. Hmm, Come on, people. Half times M. Well, we already have the number. What's the mass of the ball in kilograms? 0.535. And what's the speed right at this moment? 16 squared. Okay, 16 and sorry, u squared. Okay, let's do this in one shot. Go ahead. Okay, what do we have? Okay, so 16 squared is 256. Oops. Times 0.535 times another half. 68.48. 68.48 joules. Technically, what's the sig fig for all the numbers that went into this calculation? 3, 16.0, and 535. So what would this be? Sorry. what would this be to 3 sig figs? 3 sig figs. 64, 68.5. So 60, oh, my bad, 68.5. Go ahead. In joules. All right, 50% of the work is done. The other 50%. E.g., what's the equation? It's the easier one. M times G times H. Um, so M times G. What's the H? Right here. Right here. 1.60, yep. Okay, that's a much smaller number than 68.5, of course. So 535 times 9.8 times 1.6. 8.3888. 8.39. Perfect. And now what do I do with both kinds of energies? Or sorry, I should say both forms of energy. They're called forms because transformation. So if we add this to that, we get what? 68 plus 8 is 76, and 39 plus 50 is 89. So 76.89, yep, which to 3 sig figs would be 76.9 in joules. Great. Okay, now let's do the what? The bar fill. What do you think? Which one do you always start with? Always M, because it's always got to be filled up to how much? Max 100%, and it never changes. So all just have to shade it like this. Just make sure you go all the way to the top. Okay. Which one definitely has more fill in it, K or G at this instant? K. By how much? By quite a lot. I mean, what's the ratio of the numbers roughly? I've got 68. I've got like 8ish. So like 1 to 8. Okay. So technically, whatever you fill one of them, you should fill the other one 8 times more. Okay. It doesn't matter. Just make sure that you do it in such a way that if you stack them on top of each other, they give you what? They give you the M 100%. No overflow, no underflow. So if I choose to do this one here, if I choose to do this one up to here, how would I know how much the other one gets? Whatever is left, whatever is here, just goes there. Because if you add these, you should get this one. All right. So I'm just going to go up to here. That's it. And I have a habit to always show myself that these two add up to this one. Done. So far, so good. Okay. Now let's look at the next instant. Or instance. I'm just going to say moment. Okay. All right. What is my next moment of interest? All the way where? All the way here. Now, what's so special about any object thrown straight up, not in an arc, straight up when it hits maximum height? What happens at maximum height? How do you decide it is maximum height? It stops. It stops on 1 or 2 dimensions, or stops completely. In this case, it perfectly stops for a what? For a moment. How short is a moment? As infinitely small as it could be. Okay, we say it's 0 seconds long. Okay, so if something comes to a stop, which one of those three energies is completely brought to nothing? Something comes to a complete stop. Which one by default is 0? Because the equation is what? Half m 0 squared, and the 0 will kill off everything. So right there, you can just say what? 0 joules, and your explanation would be just what? Stops. Done. You get full marks without showing me any calculation, because you just proved to me that you understand why the shortcut works. Okay. Which one of those will never change anyway? EM. So right there, you could have actually put EM here and EM here, because it will never change. Okay, so it's 76.9 joules. So what does that leave the other player to have? How much would it have? How much in it would it have? The EG. Yeah, I mean, if this one forfeited the entire amount of money, that means this one has got to pick up all the remaining slack, which in this case becomes all of it. Yes. Oh, okay. What's the definition of EK? It's the energy due to what? Motion. At the max height, things come to a what? A perfect stop. So what does that mean? How much energy of motion does it have right then and there? I'm just saying stops here because I'm explaining to you why it's a zero. Obviously, you could have done this. And I'm not going to take any marks off. Half 0.535 times what? 0 squared. I'm a big fan of shortcuts as long as you can give me what? A quick explanation why they work. Done. Okay, so EG is, well, technically 76.9 minus 0, which is equal to 76.9 joules. Obviously, you could have just wrote 76.9 and I would have given you full marks. Okay, now, since I know EG, what's the equation for EG? What times what times what? M, which we know, G, which we know, H, which we don't know yet. Can I find it out? Yes, by forward or backward calculation? Backward. Now, what could be the equation immediately for H max? EG, if we write it here, EG equals MGH. How would you solve this for H only? Yes, you would divide both simultaneously by mg, mg. Cancel, 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 cancel. Boom. H is equal to Eg over mg. So, say again? Yes. K is a subscript, G is a subscript, M is a subscript as well. Yeah, just like forces, same thing. So Eg over mg, how much is that? 76.9 divided by the combination, not the combination, sorry, the product, I should say. Combination usually means you add 9.8. Okay, how much is that? I'm gonna multiply first, and then I'm gonna flip. Yeah, you're right. Okay, up to 14.7, up to 3 sig figs. 14.7 in what unit? Standard for distance? Meters. Okay. Am I still missing a step? Hint, there's 1.6 still there. What should I do now? Add or subtract? What should I do between the 14.7 and the 1.6? Should I add them or subtract them? How many people say we should add them? Okay. How many people say we should add the 14.7 to the 1.6? Just raise your hand. Okay. How many people say we should? Okay. From here, what did we use to measure the 1.6? The what? The gram. So the gram is the reference. Yes. So should we add? How many people say we should add? Okay. How many people say we should subtract? I'm just asking. I'm just asking. I'm going to ask for an explanation later. But how many people will vote for subtraction? No? So more people stand with what? Add. Well, the group that is right is neither. Really? Okay. Okay, Z. All right. Why do you think we should neither add nor subtract? Question for you. What's my reference? The gram. This 14.7 is already from the what? So does it already include the 1.6? There you go. You see? You see these little things that you don't pay attention to? By the way, if I gave you this as a true, if I gave you this as a multiple choice, maybe one or two would have said neither. Everyone would have been thinking, there's got to be another step still. Why? Because we did not do anything with the 1.6. And you always think everything in the problem should go into every step. Not every time. Sometimes yes, sometimes no. So what's the, what? Okay, everyone, could someone tell me, listen up, pencils down. Could someone tell me how we could have done this problem? Let's say, for example, I gave you this problem and you completely forgot about what? Energy conservation. Can you still get the 14.7? Yeah, you can. I'll give you a hint. Go back and remember what we did for the whole course. Okay, I'll give you a hint. Look, everyone, look at this strip. Forget the entire Forget the entire, sorry, let me zoom in more. Okay, everyone, focus on this strip. What do you know about this strip? What information do you know about this strip? Ah, see, what are you thinking about? Which topic in physics? You are thinking kinematics. Let's think about this. What's the initial speed of kicking? 16 meters per second. What's the final speed to which it gets to stop? 0. So how many numbers do we know now? 2. Now, is it going up or going down? Okay. Now, does it have its own engine, or is it decelerating or accelerating? So is it under 9.8 or technically negative 9.8? Do you have your three numbers? Great. Let's calculate. But now, now I'm only going to calculate what? The distance or the height. No, see, I don't want to call the height or elevation. Who said height? I'd rather not call it height or elevation. I'm going to call it what now? The distance it moved between this point and this point. Would you ever get 14.7 then? No way, because you're only getting what? This part. Then what do you have to do with the 1.6 to get the full height? Do you see what I mean? Now you're taking as if your reference was the what? Was the initial what? Elevation of the ball. Do you see? Your answer will be consistent, but not what? Identical. Identical means they're the same. Consistent means what? They're not identical, but do they work together? Okay, let's do it real quick. So, what information do we have? Vi is what? 16. Vf is what? 0. Acceleration is 9.8 with a negative. Do I care for time? Not in this case. I care for the distance. Which equation has no time in it? V squared F, VIF, 2A delta D. Okay, what's this one? 0 squared. What's this one? 16 squared plus 2. You have to put the what? Yes, otherwise you're going to get a negative distance, which makes no sense as far as distance being a scalar positive or being moving backward, which makes, or downward in this case, which makes no sense. So negative 9.8 delta D. Okay, so this becomes 0. This becomes 256. This becomes a negative 19.6 delta D. How do I solve something like this ever? Yes, you move and divide. So you get 19.6 delta D equals 256. And what happens? Divide. And if you, by the way, if you ever show step like this to a math teacher, they will take marks off. Why? Because you subdivided one part, but one side, but what? You see, always be aware of what you write as intermediate step, because you cannot always what? Legally defend. Well, I was just doing my rough work. I don't care. Every step has to what? Has to look perfect. So if you're gonna do this, you'd better what? Either what? Cancel this one or show the division. Either way, do something. So delta D is what? Can someone divide those two? 13.06, which is 1 meter. If you add 1.6 to that, what do you get? You get R 14.7. Do you see now what just happened? But then, see how energy makes it, everyone, see how energy conservation makes it a quicker approach. If you did it with kinematics, you would have to do all this, and then you still have to add how much to it? 1.6. So it's how many steps? But if you did it with energy conservation, how many steps is it? Because you already are basing everything from the what? From the ground. You already had it. Does it make sense? But at least now you know what? Two ways to what to check your answer. Awesome. All right. So, yes. Oh, okay. Hold on. I'm asking for what here? Is this delta D or height? This is height. What does height mean? How high you are from the ground, which means what? You need the full thing, not just the amount it traveled. Oh, no, no. If I did it with kinematics, I'm just telling you, what if you forgot about energy conservation? Could you still get the final answer correctly here? Yes, you could, but you would have to do a longer amount of work. Oh, because, okay, everyone, listen up. Yasmin is asking, how would I know that this 14.7 already includes the what? Because this one was measured from the what? Do you remember the special warning I gave you about EG? What was the special warning? Once you choose a reference height, it never what? It never changes, which means what? If we use the ground to measure this height, we are going to use the ground to measure what? Every other height of the ball. You see what I mean? You set a reference height or a reference elevation or a reference frame, not frame, reference, and you stick with it. Okay? Don't worry, we'll do more. We'll do more. Okay, everyone. Now, this trip, I start from what? From the what? From the top and descend. What does descend mean? Descend goes down. What's the opposite of descend? Ascend. Okay? So, okay, everyone, you keep going down, down, down until you get here. Oh, sorry, we didn't do the bars. My bad. What bar here perfectly has nothing in it? Okay, here's my question to you. Should we have a debate about not having anything, or is it a perfect zero now? Remember yesterday? Yesterday we did what? The closer you get to the ground, what happens to your EG bar? But are we ever going to touch the ground? Which means what? Some of us said what? You should have what? What? A little bit, like a sliver. And some said what? You should have what? And both of them were philosophically correct. How about here, though? Is this ball slightly moving or completely at rest now? Which means what? We should not have anything in this K bar right now. Is it making sense? This is a perfect stop. So, what does that mean? It means full to the brim. Everyone, come on. Full all the way. And which one? Which one has full fill? G, yes. Anything here? So I want you to point here and say, everyone, I want you to point to say absolutely nothing. Absolutely, absolutely nothing. Okay? Good. Awesome. All right. Now we go here. Who can tell me what the bar fill is here? Obviously, which one is still 100%? M. Go ahead. Which one should have a sliver? Sliver. Just an infinitely small amount in it. Are you telling me here it barely has any speed? It did not touch the ground yet. It did not touch the ground. So which one should have a hint of a line? And which one should almost have everything in it? There you go. Yeah. So I'm going to just put a line. And I'm going to put. Now, obviously, what did we say yesterday? Could someone say, I'm going to leave a little bit at the top? I'm not going to say you're wrong, because technically there is still a little bit at the top. The problem is it's so, so, so small. So you are more encouraged to what? To fill it all the way. Okay? Okay? So which energy bar, sorry, which energy value should I put right now in this list? Always. Yes. EM, which is 76.9 in joules. All right. Now, practically, which one is zero here? See, I'm not going to say theoretically. I'm going to say practically. Which one is near nothing? E.g. So what can we say here? I'm going to say zero. Sorry. 0 joules. And how could we now, everyone, what should we write next to it to justify the zero selection? You see, I can't say it's stop. By the way, if you say stop, it's this one that's zero. Okay? What word could I use? You could say landing. You could say at ground. Say what did you say? Start. Start. No, start means the other one. This is start, Muhammad. This is start. Technically, this is start. Huh? Landing. Everyone, landing at ground. Anything else? I don't have any more words. Does anyone else have any more words? Come on. I said landing and at ground. Does anyone else have? Uh if you want to say at reference point, that perfectly means it's at zero. I want to steer away from zero. So how about landing? Okay, everyone, landing. So landing. EK is what now? Come on. EK is what? All of it, yes, because the EG forfeited whatever it needs. 76.9 joules. Okay. How am I going to find now the what? The VF, or the pre-landing velocity. Pre-landing velocity. What rearranging of what? So you're saying EK. How would I rearrange this? Symbolically, no numbers. How? What's my first step to clean this up? Get rid of the half, multiply by 2. So this becomes times 2 times 2. So this becomes 2ek equals mv squared. All right. Then what? Divide both sides by m, so you get v squared equals 2ek over m. And that's the final equation we're going to use right now. Boom. Okay. Juman, where am I losing you? Step 1, or like this step, or this step? Hmm? Sorry. Sorry, which one? The whole, okay, hold on. Do you understand? Okay, everyone, shh, I need to explain. So, do you understand why we multiplied both sides by 2? Because I have a half. I'm not a big fan of seeing the half if I want to solve for something. How do you cancel a half? You multiply by what? How do you cancel a third? You multiply by? How do you cancel anything? You multiply by basically the reciprocal of that fraction. So the first thing is that I made it from a fraction equation to a straight equation, like straight line. Then what? I am trying to isolate what? The v. So I need to get rid of what first? Great. So I'm going to divide both sides by m. M will disappear from here, and it will appear here. What's my last step? Getting rid of the square by doing what process? Square rooting. Done. Okay? Yes. Sorry? So yeah, everyone, right now, we're just gonna write this in the paper. What's up? Why am I using oh, because I want to calculate the speed at which it touches the ground. Guys, huh? Why didn't I add EK with what? Oh, okay, everyone. What's the definition of EM? EM is the addition of what? EK and what? I can never add anything to EM. EM itself is the addition of two independent players. Well, they're not independent. What one loses, the other one gains. So technically, they're dependent. Okay. So once you find EM, you never change it. This player has got what? Zero money, which means what? This player has to have all the rest of the money. And now I have to solve it backward to find VF. Of course I am. Yes, because the only EK formula has V and the only EG formula has H. That's why. All right, everyone. So 2EK, or just 2, what's the EK? Oh, 76 over just M, which is 0.535. Should you do the square root first or clean up the inside? Of course, clean up the inside. Technically, it's a square root of a bracket. So clean up first. So we get 2 times 76.9 divided by 0.535. And then you square. Again, could it be this fast in meters per second? No way. No way. So it has to be square root. Okay. What's the proof that this answer makes logical sense? What did it start with? At what? What did it start with? 16, 0. If it comes back to the same height, it comes back to what speed? 16. Exactly. That little bit more was what was the extra acceleration over 1.6 meters of distance. So what would this be? It would be 17.0. Yes. 17. Done. That's it. Welcome to energy conservation. You just have to play with the what? With the bars and the understanding of the players doing what? Doing exchanges with themselves. Okay. What's the last question? Using what? By the way, if this was a test question, I'm not going to tell you to use kinematics. I'm just going to ask, well, how long would it stay? Sorry, would it take to descend? You have to what? You have to decide, can I use kinematics for this? Can I use energy? By the way, can you use forces to calculate time? Ever. Why? Because what's the only equation we learned in forces? F net equals what? ma. It's mass times what? Acceleration. Forces does not care about time. How about energy? Did we learn an energy equation yet that incorporates time? Also no. What is the only field of physics that we learned that incorporates time? Kinematic equation. So you are forced to go back to that. All right. But I'm only asking you for the what? For the downward trip. Okay. Well, what do I know about the downward trip? You're right. But how about we see if we have, what are all the exact ones we know? What's the initial speed at the top? 0. Okay, so that's an exact one. I like that. It's going down. So is it speeding up or slowing down? Speeding up at what good number? Positive 9.8. So now I have two exact numbers. Okay, now, do I know how much full distance it moved from top to bottom? How much? It's the 14.7. However, is the 14.7 exact or approximate? It was cut at some point. Okay, so let's put distance to the side. How about VF? Was VF that we just calculated exact or approximate? Also what approximate? So we are stuck with what? With using a what value? An approximate value out of our what? Three values. Do you see what I mean? We cannot escape it. So how should we decide which one to use? Honestly, let's look at which one of them gives us the easier kinematic equations to do. Which one would be easier? VI, A, and delta T, and solve, sorry, not delta T, delta D, and then solve for time, or VI, A, VF, and solve for time. Come on, which equation will be an easier one? Actually, tell me which equation would you use for either one? Come on, come on, come on, people. What would you use for this one? For this one? Oh, no, we don't need the VF. That's the beauty of this one. We do not need the VF. So we use the what? No, not the fifth one. Fifth one has VF. No, first one has VF. No, no. I'm saying if you want to use this and that to solve for this. Third one. So this needs equation number 3. Okay, how about if you decided to use VF? Number 1. Okay, now which one looks easier? Number 1. But VI in both is what? That makes them even easier than that. How many people want to go with number 1? Sure. Okay, great, let's go with number 1. Again, do it either way. You get full marks in my book. So everyone, let's do equation number 1. So I'm just going to, they have to be, remember, consistent. They both are what? Finding the same thing, but each one of them is using what? Two, guys, come on, two same numbers, but one different in each. Oh, okay, okay, everyone. So listen up. Yasmin is saying, but you say that's approximate. I agree. Both of them are gonna be what? As bad as each other, right? Because both of them are using approximate. So you can go back and add more numbers to the precision and then proceed. Do you see what I mean? It doesn't become a physics or a math problem. It becomes a numerical, it's actually called a numerical analysis problem. Like how correct do you want to be? But you get full marks either way. Okay? Again, isn't that what you care about? Thank you. Yes. Just get the marks. Out of understanding though. All right. So VI, come on. VI is what? 0. A is 9.8. Which one did we say we're going to use? Can someone tell me why is it not negative 9.8? Okay. Remember, one easy explanation is in this kind of motion, is it speeding up or slowing down? If it's speeding up, it's a positive acceleration, right? Hold on. What's the other explanation? Instead of using positive to point up, make your positive point what? Down. So now your acceleration is what? With the motion. You see what I mean? Either way, you will get positive no matter what. We said we're going to use equation 1, which means we're going to use VF. What's VF? Now, everyone, Can you use 17.0 as your VF? Can you? Yes. Can you go back to, fellas? Can you use 16 point, I believe it was 955? I don't care if you want to use what? An older version of the number before cutting it or the newer one. Just show me the number you're using. So I'm going to use 17. And I want to solve for delta t. Yes, you're right. You don't know only 3 things about the ball. You know what? Which means technically you have 4 equations you can use. You're right. But I am trying to what? Minimize the precision due to rounding. That's all. So delta t, what do we have here? 9.8 VF. No, we know VF. Uh, sure. Again, if you're a fan of doing the symbols first and then doing pulling in numbers, great. If not, again, it's grade 11. So I give you a mix of both. VF is what? 17 minus 0 over delta t. What would this be? Cross. This will be delta t equals the 17 divided by 9.8. That would be slightly less than 1. Sorry, less than 2. 1 point, how many seconds? 7.3. How many people agree? 7.3. Up to what? 3 sig figs or 2 decimals? 7.3. In what time unit? Standard. Of course, it's only got to take this many seconds. Ta-da! That's it. Okay. What? خلاص ممكن تروح ليه؟ Okay. One more. The more you do of energy conservation, the more you understand it, just like forces. Oh, I gave one. Okay, I'll be right back. Okay. Okay, so let's do the second one. Come on, give it a quick read. All right. Where is it? Right. Number 2. Okay, so Baha, would you do the honors? Okay, listen up.
The height of the waterfront slide is 28.5 meters.
Okay.
Kid with a mass of 22 kilograms starts moving the grass on top of the slide and goes down the slide.
Okay. Good. So, do you know the listen up? Do you know the mass of the object? Okay, 22.0. Okay. Initially, at the top of the slide, are they moving? Because they start from rest. Okay, so same idea. Okay, so at the very top, which energy of theirs is could be thought of as a perfect zero? G or kinetic? Because they are not at motion yet. Nice. Okay, let's do that. So we can write what? 0 joules. Okay, what's everyone? What's what's our explanation here? Could we write stop? Now we can use what Muhammad said. We can say starts or about to move. Okay, everyone, I'm gonna say about. Yes. Or he actually started what? He's got some motion, but the motion is so small it could be practically thought of as what? 0 joules for motion. Good. Um, do we know his elevation right then? What's the elevation of the water slide? Exactly. Question for you. So is that this side of the triangle? Is that elevation? So which part of this diagram is the elevation? Exactly. Elevation is what? Is the perpendicular altitude from the ground. This is not perpendicular. This is tilted. So everyone go ahead and just put 28.5 here. Go ahead. Go ahead, everyone. 20. I think you have enough space. Yes, you do. 28.5. I don't have enough space. You do. So I'm going to write like that. Is it 28.5? All right. Yes. So everyone, here's my calculation. 22, 9.8, 28.5. How much again, Ali? 6144. Any decimals? 0.6. All right. Okay. What's the again? What was mistake here? I called it E what? I called it E. Again, when I copy pasted, I pasted some of this from grade 12. In grade 12, we don't use M mechanical. We use T all the time. So everyone go ahead and write this as M. Okay, so it's 6144. What would this be to? What's the sig fig situation? 3, 22.0 and 28.5. What would this be to 3 sig figs? How about if you want to write it in standard notation, still keeping the same 3 sig figs? 614. Yeah, 6140. Yep. If you cut it right here. Oh, my bad. Yeah. No. If you cut it here, you would get 6140 in our book. Remember, that's always the debate. Some teachers for integers, they count the zeros, some don't. We've agreed from the sig figs day that we are going to go with the opinion that says zeros in integers do not count as significant. Okay? Otherwise, you're absolutely right. Some other teachers would say, nope, that is 4 sig figs because the zero counts now. We have decided not to do that. Okay, how about the fill? Which one is full? For sure. M is full whether we like it or not. That's how the universe is. Okay. Which one should have practically nothing? K should have practically. You want to put a sliver because they are slightly moving? I'll leave it up to you. I am not going to do that. So I'm going to fill the entire G. When you teach physics, you have to teach this way. You have to tell people that physics is as an exact of a science as it could ever be, but there's still room for what? For interpretation, for style, for layout, for presentation, and so on. So plus. And math is the same way. Okay, done the first part. Second part. Where are they now? Sorry, halfway. What does the question exactly say? Halfway down the slide. They didn't say halfway down the elevation. They said halfway down the slide. Do I know how fast they're moving right here? I do know they're moving though. So I know they have somewhat. And are they still technically not technically? Are they actually elevated still from the ground? So they do have somewhat. Some EG. My question is though, Which one can I calculate? Obviously, which one do we know for sure now? EM. Let's call it EM. Everyone, EM. And what are we going to say? We're going to say 6140 joules. Now, which one do you know now for sure? Oh, sorry. Can you calculate now for sure? EG or EK? Come on, think. But I don't know their speed. Great. So I can't know EK. So logically says what? If we don't know one player, we definitely can know the what? The other player. But my question is, what's my elevation here? I am not telling. I'm only telling you they're only halfway down the slide. I did not tell you how much above the ground they are. So Yasmin is saying, just divide the full height by 2. I said halfway down the slide. I did not say halfway down the. Find the hypotenuse. Okay. Abayo, I'm giving you this question to make this. She's saying find the hypotenuse. Any other suggestions? And then divided by half. But okay. No. Hold on. But that would still not give me this. That would only give me this. I don't want that. That's not elevation. Elevation is this. How am I going to find it? Sorry. Say it. Like the full thing? Okay. Uh-huh. But if I'm going to end up dividing this guy by 2, why am I even bothering with finding this guy? I mean, I'm just answering your follow-up. No, the 20 meters has absolutely nothing to do with the question yet. Yeah, the 20 has nothing to do with part A of the question. 20 is only going to be used for part B only. The question is so simple using a math. Everyone, check this out. It's a grade 9 question. Yep. I am 100% serious. Is this a good side profile of the slide? All right. Where are you? Where is the kid right now? Halfway down the what? Hypotenuse of the slide. So where? Let's say roughly here, right? No, there's no Pythagoras. Okay. You're right. Get out. Get out. Cosine law? Aren't you the master of overkill? Everyone, we're trying to find this length, right? Come on. Are we trying to? You're right. It's a right angle triangle. So might as well add that to it. No, you're right. Okay. Question for you, everyone. I'm going to connect a line. What math does this remind you of from grade 9 and 10?
No shit, really?
What'd you say?
Triangle math.
Keep going. No, you should go. He at least got closer. You went like left field, man. Come on. Which kind of math? Grade 9, 10. Or should I go tell Fonseca and should I tell Fonseca and Shivers? Fonseca and Shivers do not need more reasons to believe less in this generation. Nope. Similar triangle. Yes. Similar. Yeah. Think of everyone. No, hold on. What can you tell me about those two lines? They're parallel. What does it say when two triangles are similar? How many angles do they share? All of them. So that means what? If this one is parallel to if this one is parallel to this one, what does that tell you? Is this angle the same as this angle? Of course, this one is equal to that one. Is this one equal to this one? Yes. And how about this one? It's technically the same in both because one of them is a magnified version of the other. So I'm just going to use a double line. So what does that tell you? See, similar triangle power is not saying that the angles are the same. It's saying that the ratio of the sides are the same. What does this mean? If this guy is half of this guy, what is this one as well? Half of that, which means what? This one is what? Is half of this one. Does that make sense
I
now?
didn't know this is like March of last year.
Why do you think I love teaching this course? Every day I will tap into something that you thought you knew. I'll prove to you that you forgot it. But now you know. So, yes, good. Are these two triangles similar? Great. So if I know the ratio of two sides, I know the ratio of all the sides. I told you he's how long down the slide? Half, which means this length is half of what? Which means this side also has to be what? Half as big as this one, which means what? This side has to be half as what? What does that mean? How long is this one? As big as this one. Yes, it is. But you know what? If I just told you divide by 2, you would have never had the chance to review this, and you would definitely have had to see it.
Why
What?
am I doing still the right answer?
Yeah. But you couldn't explain it. And I'm the last teacher to care about the answer. I want to know if you can explain it to a 5-year-old. None of you could. No, I'm 41. That's what I am. I've been in the trenches for too long. Experience, yes, David Beckham. All right. So what do we say now? How high are they above the ground? You divide by 2. But now you know why. Because of similar triangles. Okay, everyone, go ahead. How long is this one? What's half of 28 and a half? Well, half of 28 is how much? 14. 14.25. Yes. All right, let's do that. So 22, 9.8 times 20. Sorry. Do you have enough space for that? I don't. 14.25. Come on. Couldn't I just have taken, listen, couldn't I just have taken the old E to EM and divided by what? Yeah, I mean, nothing changed here. Nothing changed here. The mass, sorry, not the mass. The elevation changed by half, which means what? The final answer now is half of what we got before. What was half of this? 6144.6, right? Right? Divided by 2. What would this be to 3 sig figs? You're right, 3070. So how much is left for this guy? That's got to be the subtraction of what? 6140. Guess what? It's got to be 370 as well. Which makes sense, right? Half of their energy now is gravitational. So how much is left for kinetic? The other half. Thank you. Where the what? Half the energy seeped into the EG bar. So how much is left for the EK bar? Half, which is also identical to the EG bar as well, right? Okay. So, by the way, just so you know, everyone, energy conservation is, by the way, those, listen up, those questions might seem not confusing, but at the end of the day, you're like, oh, yeah, that all made sense. You will, I'm telling you right now, you will struggle so much with the questions in the practice assignments and on the test because you will have to do all of the what scenario I did myself with you completely on your own. This is not easy. It's like F net equals MA all over again. You have to do it. All right. So 3, you disgraced what? What? Oh, no, you didn't. No, you didn't. I and him, I mean, myself and him and Shiv as well, we're teaching with cohorts online, and we knew every time we turned off that Google Meet that no one understood anything. And I hated myself every single time because, like, what am I doing? 3.5 hours of trig? I don't like trig that much. And I'm a math guy. But we had to do what we had to do. I'm glad that those days are behind us for sure. Okay. How would I get V? Hmm. Same equation we just used for the last one. Let's use the final answer or the final form, my bad. What was the equation? Square root of what? Come on, who remembers? 2 EK divided by the mass. Let's do it in one shot on here. What do I get? 2 times 3070 divided by, what's the mass? Could that be the kid's speed? Square root this guy. What do you get? 16.7. By the way, you can tell by me putting this example up that I'm not really a big fan of kids. Yeah. Multiply this by 3.6. Go for it. Come on. Multiply this by 3.6. Because that's the conversion from meters per second to 3 kilometers per hour. 60 what? 68 point. I am designing a slide that the kid is only halfway down and they're all already going what? Over 60 kilometers per hour. Yeah. Okay, everyone. How much again? 60 what? Sorry, 60. 60. How much? Oh, no, no. Just a random answer. 60. 60 kph, kilometers per hour. All right. Hold on. By the way, what? Talk about Canada's Wonderland in your own backyard. Okay. Where are they now? If they were good. If they did not piss off Mr. Ramadan. Okay, this is getting slightly too dark. Okay, I'm afraid I opened a can of worm, a very bad can of worm. Okay, are they are they almost at ground level? So which one is practically zero? No, G. All right. So let's write 0 joules, which means again with this need to be M and 6140, which means what? EK now is what? No, how much? All of the what? All of the forfeited by the EG. 614. Oh, sorry, we did not do the bars here. What should be the bar fill here? Exactly. No, here. Sorry, here. Again, we said half lost, half gained. So half, all. Yep, done. Okay, this one. Well, full for the EM, of course. Is this the sliver one? Is this the little sliver example? Yeah, it is. Because you could say practically, officially, they are not at ground level yet. But you could say, well, you know what? We are going to say they are. So if you want to put a sliver, go ahead. Sliver means a very thin line. And then, okay, listen up. Question for you. Are they now all the way down to the ground? No tricks, no tricks. What was their speed? Everyone, pencils down. What was their speed halfway down? How fast were they going? 16.7. Now they're what? Now they're what? All the way down. So what happened to their, what happened? Come on. What happened to the length of the slide? No. Don't read too much into this. Answer the question. Halfway down the slide, they were how fast? Now they doubled their length, right? So what happens to the speed? It doubles. So what's the double of 16.7? No. That's the wrong guess. I am going to prove to you that this line of thinking is wrong. You can't just say, oh, I double my distance. I also double my what? It doesn't happen like that. But let's say you thought so. What's the double of 16.7? Come on. 33 point. So someone says, oh, I didn't need to show him a calculation for this. Double the distance, double the speed. I'm going to get to what? More. Okay. Oh, which, by the way, is how much? Is 100 over 121 kilometers per hour. They already are getting a speeding ticket on a slide. What would be wrong about doing it this way? Officially, everyone, come on, focus on me. Officially, what's the correct way of finding V? If you know the energy K, you have to do the what? You have to do the square root calculation. Let's see what it gives us, everyone. So square root 2 EK, which is how much now? 6140 divided by still what? 22. How much is that? 6140 times 2 divided by 22. Did they get to 33.4 meters per second? No, they got only to how much? 23 point. My question is, by the way, that is the correct answer. So go ahead. Go ahead. Copy that. No, don't copy this. Copy this down. Equals what? 23.6 or 7. Come on. 23 point. 0.6 meters per second. Can someone multiply that by 3.6 to tell me meters? 85. All right, 85 kph. My question is, how come they did not double? How come sorry, everyone, how come the calculation wasn't that simple? How come the calculation wasn't that double distance, double the speed? Why is this not working? Oh, I'll tell you why it's not working. Everyone, look, everyone, eyes on the screen. Because of the what? What was the original equation for EK? Half mv squared. Is it a linear equation or a quadratic equation? What does that mean? Are things changing in the same like tone or in a different tone? Why? Because you don't have it linearly where if you double, you double. No. Now if you double, you what? You square. No, you square. So that means what? If things are not linear, you cannot just say, oh, double, double, triple, triple. You have to actually do the what? You actually have to do what? You have to do the math and this time idea. Is it making sense? Again, unless you're okay. Question. Oh, hold on. What's the equation for EG? Come on. What's the equation for EG? MGH. Is any of them squared or cubed or square rooted or anything? So is that a linear equation? What does that mean? Can you then think, oh, if I double this one, I would double this one? Yes, but the problem is, what's wrong with the V in the EK equation? It's being what? It's not linear. It's non-linear. Done. Curves do not go what nicely. You have to do the math. Done. So the speed of the kid at the end of the slide, right before hitting, is 23.6. Okay, last one. Come on, Ali. What's last one? Okay, now what is this one? Literally just calculate the what? The hypotenuse of it. Okay, do we have a right triangle already? Do we know both right sides of it? Yes, we do. C squared equals A squared, blah, blah, blah. C squared, 20 squared plus 28.5 squared, which means C is equal to the square root of this guy. How much would that be? 20 squared plus 28.5 squared, square root. How long is the slide? The actual metal surface of the slide. Come on. How long is the slide? Huh? Right there. 34.8 meters of length. Meters per second or just meters? Meters per second or just meters? Meters. It's the distance. Okay. How long? Come on. How long? Listen up. Come on. How long does it take the kid to clear the whole slide? I don't know. Hold on. Do I know how much their initial speed was? At the top of the slide. Come on. How? 0. Do I know how much they traveled? How much? No, no. How much? How long? Sorry, how long? Do I know what their final speed was right at the end? Do I know 3 things? What if someone says, listen up, Ali, come on, Zayon. What if someone says, I know their acceleration? And you're like, really? What? And they go, they're falling, so it's 9.8. Oh, no, you know what? Even if there was no friction, their assertion is wrong. What if someone says, oh, their acceleration going down is 9.8? What did That's my point. Are they free falling or is there a support surface? Sorry, so it's not 9.8. Don't fall into the trap of saying that anything that goes down is what? No, it's 9.8. It's less. Why? Because they're what? Are they going straight down or tilted? Oh, there's no way they are 9.8. They are less. So you can't say 9.8. But do we have 3 numbers? Great. Let's find it out. So VI is what? VI is 0. Come on. VF is what? 23.6. And delta D is what? And I want delta time. What's missing from this list? What's missing? Not unknown, missing. Which equation has no acceleration? The second one, which we barely use, but it's there. Half. All right. What's delta D? 34.8. Half is half. VI is 0. Good news. VF is 23.6. Delta T. What's half of 23.6? 11.8. What do I do now? Divide. That's got to be slightly, is it almost 3? Almost 3. 2 point what? Is it? Less than 3 seconds to go from a height of 28.5 down a slide that's about 35 meters long. Yep. Okay, so let's look at this. So we have a mass or a block. Do we know the mass of the block? How much? 2.10 kilograms. Okay. Is sliding down a frictionless ramp as shown below. You might say you didn't give us ramps before. You're right. I didn't. Exactly. I gave you a slide which is the exact same geometry kind of a ramp. Okay, so frictionless ramp as shown below. When the box is at a height of 3.2 meters above the floor or above the base of the ramp, like right here, it is observed to be going at a speed of 6.3 meters per second. So interesting. So at that instant, right there, right here, do I know all the energy information of the box? Let's think. Is this box moving right there? Yeah, you can see that it's actually what given some wind effect and some motion. So can you calculate the EK of the box at that moment? Oh, sorry. Right here. The last one. Yeah, there we go. Okay, who doesn't have this sheet? Come on. You all have it? Okay. So can you calculate the EK of the box at this instance? Do you have enough information? Yeah. Yes, because what's the equation? EK equals what? Half mv squared. Got it. Can you calculate the EG of the box at that instant? EG. Yes, because what's the equation of EG? M, which we have, G, which we always have, and H, which is the elevation, and we do have it at that time. Great. So even before finishing the question, can you do part A? What is the mechanical energy of the box at the 3.2 meter height of the first ramp? Can we do it? Yes. Okay. So let's do this. So EK, whoops, sorry. So EK, I just have a habit of starting with EK. EK equals half 2.10 times, what's the speed? 6.3. And don't forget the square. All right, 6.3 squared. Okay. What do we have here? Okay, too big. All right. Okay, 6.3 squared times 210 times 0.5. What's the specific situation for everything? 3. So, by the way, technically, is this your final answer? No, because the question is asking for what is the what, which means you are waiting until you add everything up. So let's keep one extra digit. So if I keep 4 digits, what would it be? 41.67. Okay, so 41.67 in joules. All right. How about the EG? M, G. What's H? 3.2. All right. What do we have here? 210 times 9.8 times 3.2. Okay, if I stop it at 4 digits or 2 decimal digits, what would I get? 65.86, 65.86, 65.86 in joules. And finally, my EM equals 4167 plus 6586. What do we have here? Well, that 60 and 40 is 100. 1 and 5 is 6, but it will cross to 7. And 6 plus 7 is 3. And then 8 plus 6 is 5. Right? 6 and 7 is 13. 1 is 8. Yep, that is correct. What? Grade school addition? That's not a damn bro situation. I am concerned for your generation. Okay. Oh, so we're done. Okay. What would this be to 3 sig figs? 108. So cut it right here. So you get 108 joules. So which one of these 3 numbers will never ever change. E, which will never ever change. EM, right? It's the total amount of what? Of energy in the system being the box. Okay, so we got this all checked out. All right, now let's keep going. It is then changes to a frictionless horizontal. By the way, why am I keeping the fact that it's frictionless all over this ramp, this floor, and this? What would happen, everyone, if there was friction? What does friction do to any system? Add or take energy from it. So that means what? If I say right now, do we know the speed here? Okay, something is sliding down. It's definitely what? Slowing down, cruise controlling, or speeding up? Speeding up. So we know that it should be here what? Slower, same, or faster than here? We know it should be faster. The problem is what's the difference in the speeds here between the friction situation and the no friction situation? Where would it reach here at a faster speed when there's friction or no friction? Exactly. So what's friction going to do? It's going to steal some energy in heat in the what? In the what actually? Within the what? Within the body of the ramp itself, which would help us with the calculation or screw up everything because we don't know how much we're losing to friction. Okay, by the way, in grade 12, we do incorporate what? Sliding over ramps with friction, and we will do the problem both as forces and both as what? Energy and work, and we will see that the two answers at the end are the what? Are the same because both approaches are consistent, not identical. Consistent means they both give the same thing. Okay, frictionless horizontal surface where it keeps what? Moving for a distance at the what? Of course. Question for you, everyone. Even though we don't need FBDs, but can someone tell me the FBD of the box in this region? Come on. What's force number one? FG. It's there. What's force number two? Okay. Obviously, it's not sinking down or jumping up. So what can you say about these two forces? They are equal, which means the F net vertically is what? Zero. Okay. Now, is anything physically pushing it forward? Is there any explicit applied force? Okay. No, no. Force. Momentum, by the way. Momentum is usually what? Related, but different concept than force. Is there anything forcefully pushing it? Is there anything forcefully pushing against it? Not in this case, because I explained it's what? So that means what? Horizontally. Are there any forces on it? So what does that mean? It's the astronaut in space principle, which is what? You push them. What happens to them? They speed up, and then you let go. What's going to happen to them forever? Move forever in the same what? In the same direction, because nothing is pushing and nothing is pulling. Good. And then it what? It then starts moving up another what? Another frictionless ramp where it slows down until it comes to a what? Do you see how this resembles kind of a pendulum? Again, if you leave it to its own devices, it should never what? It should never stop. Have you ever heard of something called, it's maybe some of you have heard of that term, perpetual motion machine? A perpetual motion machine is a machine that's impossible to make anyway. What does that mean? It's a machine, listen up, that you get to move once and it never stops what? But that's impossible because what's the only force that you can never eliminate from the universe? Friction. Anything that's moving is going to have what to what? Have to what though? Slow down sometimes up to a what? Up to a stop. A perpetual motion machine what emphasizes that no, this machine will never what? Will never end moving or stop, which is impossible because friction you can never eliminate. It could take eons and centuries, but it will come to a what? A stop at the very end. No, no, no. See, that's my point. The perpetual motion machine is fixated on the condition that you give it an initial amount of energy and you never keep feeding it to it anymore. That's the trick. Obviously, because you can just keep what? Pumping energy to the system and have it what? Move all the time. No, it's saying give it an initial amount, an initial burst, and leave it. There's no way it's going to move what? Forever. By the way, it violates what we call what? The first law of thermodynamics, which is the conservation of what? Conservation of energy. Thermodynamics, by the way, has nothing to do with math. Thermodynamics has to do with what? Energy, heat, all of that stuff. Okay, so what's the second question, everyone? What's part B of the question? No, whoa, 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 whoa. Did you say millisecond? If it was ms without the slash, that I agree with you then. It would be like millimeter, milliliter, millisecond. By the way, can you ever measure speed in some kind of a scale of seconds? No, seconds only measure what? Measure time, and that's it. How would we actually find out how fast it's going right here? Okay, when it reaches right here, exactly right here, what practically came to zero? The speed or the elevation? So what practically will go down to zero? The EM, the EK, or the EG? Nice. So now we're going to do the exact same what? The exact same shortcut we did before. What are we going to say? EG equals what? 0J. And what's the explanation? Do you remember the word we used yesterday? No, I can't say stops. Stops means EK is 0, which is completely what I don't want. What do you say? I use the word landing, which means it's basically as close to the surface or to the ground as possible. So we're going to say landing. All right. Okay. What's EM? Actually, I should have started with EM. It would have looked nicer. Yes, EM is what? 108 joules. So according to this, what should be EK? Because one player has nothing, the other player has to have every single thing in their possession. So 108J. Okay. The question did not say what's the EK at that level. It said what's the speed. Can we calculate the speed now? Absolutely, by reverse calculating the V. So let's go. So what's the equation? EK equals, so I'm going to say 108 equals 1 half 2.10 V squared, which is 108 equals, what's half of 2.1? Well, half of 2 is 1, and half of 10 is 0.5 V squared. Okay, what do we do now? We divide and then square root. So technically, V can be in one shot done like this. 108 divided by 105 as a square root. How much is that? Well, 108 divided by 1.05, which is very close to 108. Yep, it's 102. And then you square root this guy. Sig fig situation up to 3 gives me 10.1. 1? Yes. 10.1 meters per second. What's the only logical check that this answer makes sense according to the values we have on the diagram? Thank you. It is what? It is faster. Can you argue? Think. By the way, did I ask you to fill in the bars here or no? No, I am not. I am almost never going to ask you to what to do the bar approach. I do it just for one day to get the idea across. Can someone tell me what's the bar approach proof that this has to be faster? Bars. Initially, were all the bars full? Sorry, were all the bars filled to some extent? Initially. Come on, initially. In here. In here. Yes, the EM was full to up to how much? 100%. The EK had some, and the EG had some. How about now? The EG has to what? Diminish, which means the EK has to what? Pick all of that up, and then what? You get could it ever get faster than 10.1, everyone? Could it ever be moving in the entire problem faster than 10.1? Come on, what do you think? Come on, look at the values, look at the diagram. Could it ever be moving faster ever on the horizontal surface or up here than 10.1 meters per second? But why could it never go anywhere in the problem faster than 10.1? It has nothing to do with acceleration or deceleration. Think of it from an energy perspective. The question is, why could it never ever in the problem achieve a speed higher or faster than 10.1 meters per second? Think of energy bars. Energy M is constant, and right at that moment, which one of the two players is full? No. Which one of the two players? EM is not a player. EK. Has EK been fully filled? Yes. Could it ever get more? Which means what? Could the speed get any higher? Thank you. See, you see, honestly, okay, you can probably, I'm hoping you're starting to see that what the thinking in energy is kind of sometimes easier than thinking in what kinematics, acceleration. Why? Because you know you have what a max amount that you can never go what above or beyond, which means you know what? I don't even care about kinematics. I can tell you, you will never be faster because you can never feed more to the system than this energy. Nice. Okay, last one. What maximum height right here could it get up to? Obviously, what happens at any maximum height? What does happen to the object? It comes to a what? It comes to a full stop. So now here, does it have any wind effect or perfect stop? Okay, let's put the shaky lines here like this. Shaky lines. All right. So it has to be a perfect stop, which means what? Is it a sliver in the EG bar or nothing? Sorry, in the EK bar or nothing? Absolutely nothing, because I just said it's a perfect what? It's not an approximate stop. It's a perfect stop, like when you go like this. Right there, it came to a stop. For how long? For a moment. How short is a moment? The shortest ever. Who cares? Okay, so right here, stops. Go ahead, stops. Okay, so let's do the calculation. So EK equals what? 0J, because it stops. EM is still how much? 108, because that's the max amount of money in the system, which means EG has to be what? 108. And let's calculate the what? The height backwards. So what's the equation? 108 equals M G H. By the way, if you just call it H, not H max, although technically it should be called what? H what? Max, because technically it's a very special moment. It's the one where one energy is completely zero. So that means H max equals 108 times 210. Sorry, divided by 210 times 9.8. Say again. 5.25, and that is indeed 3 sig figs. So we are correct. Okay, everyone, reason to me from the diagram why it is possible to be able to go up to 5.24. By the way, question for you then, everyone. Is it, where is the 5.25? This or that? And you have to tell me why. Why can that not be 5.25? Okay. Why can this not be the 5.25? Hamad, why? Technically, that's the ramp, not the ground.
Yeah, but no, but the H max, like arrow, is from the ground to the
Okay. Okay, hold on. What's your? Ah, okay. So I'm gonna rephrase what you just said. But Baha, what did you say? Okay. What did we say about the word elevation or height? Can you be tilted when you measure it, or do you have to be perpendicular? Is this perpendicular to the ground? No, it's not. Is this perpendicular? Awesome. So that's reason number one. Reason number two. Hamad what compared the very final instant to the very what? Initial observation instant of the what? Of the system. He said that here we were able to climb up to what? How much? How much did we get? 5 point. How high was it here? How come here it wasn't 5.25? No. Okay, I have a question for you. Imagine if it cycles back. How high would it go up? You see, energy makes you analyze things without even needing to know the what? Needing to know the angle. Is slower, sorry, smaller than, less steep than this one. But my question to you is, regardless of the angle, if this one slides back, would it stop here or keep going? That's the key. It will keep going until it achieves what height? Do you see what I mean? That's why I call it like a what? Like a what? Like a pendulum. Make sense? It has to go back to the same what? To the same height as before. Imagine if you did not know how to analyze it with what? With energy conservation. What would be then the only way to know how high it gets? You have to do two things. Everyone, you have to do what? Kinematics. Oh, you're not done yet. Kinematics only will give you what? How far it travels on the what? On the what? On the ramp. That's not my height. That's only the distance traveled in space, like up. What do you still need to do? Not or so so katoa. Okay, everyone, let's listen up. Let's play what I like to call devil's advocate. Let's basically say, what if we didn't know energy? How would you be able to calculate this one? Well, first of all, you can't do this one. You have got to do this. we have to do kinematics. What kinematic stuff do I know about this? At the bottom of that ramp, what's the speed? Right here. No, 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 no. When it reaches here, before it starts climbing and slowing down. Nope. But 6.3 was when it was here. What's the speed here? How many people say it's 10.1? How many people say that the speed here is 10.1? Okay, relax. What's the speed here? As it goes down, what's happening to the speed? Increasing. What did we discover? It reaches at this height, 10.1. And then it keeps going with no what? Is it speeding up, slowing down, or cruising? What does cruising mean? Your speed stays the what? 10.1, 10.1, 10.1 until it hits here. So it starts going up the ramp at what speed? 10.1. Make sense? Okay. Goes up, goes up, goes up until it comes to a definite what? Which means what's the speed here? Okay. So we know the VI, we know the VF. Do we know the distance? No, I don't. Do I know the deceleration it goes through? Do you know the time it takes to slow down to a stop? Guess what? With kinematics, you cannot do this. Imagine kinematics with all the things we were able to do with it, it completely fails because we're only up to how many givens here? We are still missing what? Guess what? In grade 12 physics, we will be able to do this with what? But before kinematics, we have to do it with forces because I have to give you the what? The friction coefficient of this guy. Do you see what I mean? Sorry, not the friction coefficient. There's no friction. There's no friction. I will show you how to what? How to do the forces when you have what? When you have what? When you have an angled ramp. Grade 11, we do not do angled ramps. It's just not a part of the curriculum. Grade 12, we actually, what's up? Then we would have the distance, and then we would have what? We can find out how much distance here, okay? But then I still have to give you the what? The angle. And then you can do what? So, ka, toa. By the way, would you use so or ka or toa for this? Let's see. What do you call this in the triangle? Hypotenuse. So we will figure that out in grade 12. Now you need this guy. According to this, what is this one? Opposite. So you need to relate hypotenuse to opposite. That's only relatable with what? With sine. Opposite over. But you need the what? You need that. You see how little information you need to do it with what? Energy can give you the full story with minimum amount of what? Pun intended, work. Make sense? I know. Lame. Need the light. No, that's fine. Okay? That's it. Okay. I have one last question before we start the review. Reason to me why it could never go up on the ramp forever. The ramp doesn't stop. What if the ramp was endless? Could this move endlessly on the ramp? Say again? But I don't want you to use forces or kinematics. I want you to use the new stuff we learned. What makes it mandatory for this to definitely come to a stop at some point? Max what? But that's my question. Why is there a height max? Why should it stop? Remember, can this box ever have more than 108 joules in it? No, it can't. So let's do, by the way, listen up everyone. There's a proof method in math. It's called proof by contradiction. You might have seen it once. Mr. Shivers is an expert in it because he did pure math as an undergrad. You prove a statement by what? By assuming what? That the opposite is correct. Do you see what I mean? And then you find out that, oh, we got to the wrong conclusion. What does that mean? Our initial conclusion, our initial assumption was what? Was wrong. So it must what? The opposite must be right. Okay, it's called proof by contradiction. So let's say that it could move forever. What does it mean to move forever? Even if it moves at the same speed. It's not the speed that matters. It's the what? If it moves forever, what's happening to the height? And if the height increases, what bar goes up as well? E.g. But at some point, it's gonna what? It's gonna exceed what? EM, which is how much? Can you ever exceed EM? Which means what? Do you always have a glass ceiling you can go to? What does that mean? Does it have to stop at some point? Yes, it will stop when its maximum EG becomes what? 100 and? Okay? So remember, you cannot exceed the maximum. And that's it. Okay? Definitely. Yes, I will give you 2 energy conservation question on test. One of them is a straight line motion up and down like the ball, and one of them with, I don't care, like I call this the roller coaster thing, right? Like basically when you go up, you slow down. By the way, why do you slow down when you go up? Because as you go up, what energy bar goes up? EG. So that means what energy bar has to go down? EK, which means your speed has to also what? Go down. And then why do you speed up when you go down? Because it's the what? It's the reverse. It's the opposite. Your EG is going down, which means your EK is going up, which means you have got to speed up. Okay. Okay.